Good morning, everybody. Yeah, it's still morning. Good morning, all. Thanks for joining us today for our first finance webinar of 2021. And we are going to speak about modern MATLAB for finance professionals today. Great, so just some housekeeping before we start. Just to let everybody know, please ensure that your microphones are switched off and your cameras are also off, just for some bandwidth and for the flow of the presentation. But if you have any questions during the seminar, you are more than welcome to ask any questions to the chat, or you can save them for the end for our Q&A session. Please note that this webinar is being recorded. So before we begin, I'd just like to give a quick introduction about who I am, although most of you probably already know from the webinar invitation. But a quick summary: my name is Leo. I am a solutions engineer at Opti-Num. I have a aeronautical engineering degree from Wits University. And you're probably thinking, well, why am I presenting a finance webinar today? Well, I like to think of myself as a finance enthusiast. If you'd like to contact me, you are more than welcome to contact me on my email address or connect with me on LinkedIn if there's any questions you have following up from this presentation. And yes, that is my best photo. Cool. So as the agenda for today, we will be looking at a model development workflow and then how has MATLAB evolved over the last couple of years from programmatically coding to apps and live tasks and really interactive workflows that you might have. And then we're going to look at the demo where I'm going to demonstrate all of these different capabilities for you today. Once the demo is done, we'll just jump into what the Computational Finance Suite is and the tools that I use throughout the demonstration, some key takeaways, what's next, and a couple of FAQs at the end. But without further ado, let's jump straight into it. So I'd like to just start off with what are the MATLAB enablers for rapid model development. And there are really four key things I want to bring to light today in this webinar. The first is that you will be empowered to develop as fast as you think using the tools and techniques that I'll be able to demonstrate to you today. You'll be able to create transparent model. You'll be able to develop transparent models throughout your work and really be able to then make sense of the data that you have to be able to interpret and understand how you've created these different models. Then the last thing I want you to see is that there are really in-depth integrated financial workflows that you can create to develop as fast as you think, create rapid prototypes of models, test different things out to see what is your data doing. So before we touch on to anything else, I'd want to just speak a little bit about the model development workflow that I keep referring to. So the first thing is on the left-hand side, we have the access stage where you have files, databases, or you're collecting data from your data feeds. And you need to pull that data into some sort of environment to research and quantify what you're looking at. And perhaps you want to do some data analysis and visualization. Maybe you're doing some financial modeling, or you're developing applications for somebody to use. But then that needs to be integrated into some sort of reporting and sharing format. Perhaps it's additional applications or an enterprise IT system for your production. And you really need to be able to automate this whole process. And I'm going to touch on some key things that you'll be able to use to really work in this left-hand side and the middle sector really, really well. But if we break down this model development workflow a little bit, we can go from the left-hand side with your access and explore data. You then need to pre-process the data. You might need to do some feature engineering, model training, model tuning. And then once you have this model, you need to integrate it with some IT enterprise system. So what I'm going to show today is a lot of different things of apps that can allow you to explore the data, to access your data, live tasks that can allow you to pre-process your data easily without even using any code. Some feature engineering, perhaps you're someone that's working with alternative data sets, image data, signal data, sound data. We won't touch on that too much today, but there are these things available. In terms of model tuning, there are apps for regression, classification, econometrics. There really are a lot, and I'll show a couple today, and we'll actually dive into some of them today as well. But then, of course, you move on to your model tuning and you have some hyperparameter optimization that you perhaps want to do. We're not touching on that too much today, but there is that available. And then, like I said, once you're done, you need to integrate this into some sort of enterprise IT system. So I mentioned a lot of different things that I want to bring to your attention today. I mentioned things like live tasks, apps, and there's also the live editor. And this is really how MATLAB has evolved from programmatically creating models to being able to interactively create models by literally pointing and clicking, and then automatically generating your code. So I just want to touch on these three things before we jump into the demo of how you can use them to create the models you want to create. So with the live editor is literally a living white paper where it's a live script that you can embed text, code, so much more. This is what really helps you create these transparent models. And there's so much available in the live script that I'm going to touch on today, but you can also take this live script to share it with other people, whether or not they have MATLAB. But in this live script, you can embed live tasks. And live tasks are literally, they're lightweight apps that you can include, and they can allow you to explore parameters and options. But you have live tasks for optimization, for plotting, for pre-processing your data, and so much more. And you can generate the code for that so that you can automate that whole process. And the last thing I want to touch on today is the apps. And the apps really allow you to use your domain knowledge without getting tripped up by any code. It's literally fully interactive workflows, point and click, and then you can generate your code afterwards. And there's apps for machine learning, econometric modeling, database access, and so much more. So what is the demo we're going to look at today? Well, we're going to try and predict or trying to forecast some time series model. So we're going to bring in some data, historical data, using the data feed toolbox from FRED, which is the Federal Reserve database that we have access to. We're going to use MATLAB to do all of this, and then use MATLAB to split our data set into a training and a testing data set. And then we're going to build three different kinds of models and compare them. And the first model we're going to build is an ARIMA model with the econometric modeler app. We're then going to forecast and create a simulation for it to see what the result is. We're also going to use the regression learner app to forecast a model. And then what I'd like to also do is show you how you can integrate with different languages. But in this case, we're going to integrate with a model that has been built in Python. But you're probably wondering, this is MATLAB for modern professionals. Why do I want to integrate with Python? So perhaps you're collaborating in a bigger team and there are different members on your team that use different languages, and you're comfortable perhaps in MATLAB or you're comfortable in Python. And to work most efficiently, you want to be able to integrate with each other to really get the best of both worlds. You can also reuse existing Python code that has been built, so you don't have to rebuild it from scratch in a whole nother language. Or you would like to leverage some of the specialized libraries that have been built on the open source market in Python, and they're not necessarily already implemented in MATLAB, but you can use those specialized libraries really from the get-go. So let's jump into MATLAB. So for those who have maybe not used MATLAB that recently, this is what the new MATLAB interface looks like. You have your toolbar, your current folders, your command window, and your workspace. It looks a little bit differently over about the last 5 or 6 years. But what I have in our current folder is a project. And this project holds a whole bunch of different files. So it holds some data files, it holds the demo that we're going to look at today, it holds some helper functions, some additional models, and you can see there is the Python script that we're going to use, and it holds some things like shortcuts. And projects really allows you to store all the folders that you want for your project in one place and easily integrate that project with something like source control. But as your projects become bigger and bigger and bigger, you need to be able to manage all these different files that are created. And this is how you can really do that quite easily. But what I'm going to do is I'm just going to double click my project so it runs all my startup functions that I have to add all the necessary files that I have to my path, so I don't have to worry about any path management during the demonstration today. And what we're going to do is we're going to open up our demo, and I'm going to open up the live script that I've been talking about. But you'll notice that this is the skeleton live script because I'm going to do as much as I can live with the time provided today. But there is a pre-built one that we'll share with everybody after the demonstration. So what I have over here is the live script, and you'll see that it's a live script because it's donated with MLX. And right now you can't really see any code. There will be code at the bottom. But what we have here is the living notebook. Headings, we have different file formats. We have things like hyperlinks that you can use, a table of contents, so that when you share this with somebody else in perhaps a PDF format, it's a living report that you can share with maybe someone like your manager or someone on a model validation committee if you are in that current role. And to insert all these different things, you can go to the Insert tab where we have code, controls that we're going to touch on, some live tasks that I've been mentioning. You can add section breaks into your code so that you can only run a specific section and not have to run the whole script when you are developing your models and doing iterations throughout. But you can add things like a table of contents that we have here that gets hyperlinked, code examples. Perhaps you want to add a piece of pseudocode to help make your code more understandable to somebody that is busy reading this. But you can also add images, hyperlinks, and equations to really make this a living notebook. But I said we're going to do a demo and we're going to do more practical things. So let's jump straight into what we're going to do and forecast these different models. And the first thing we need to do is we need to import some data. And what I'm going to import is some data from Fred. And the way that you can import data from Fred is by using the built-in MATLAB fetch function. And that fetch function looks something like that. And it needs 4 inputs. As you see, it gives you some contextual hints of what you need to do in MATLAB. So the first thing we need to input is the object. What do we want to connect to? So I'm going to give that a variable name, and you'll see why. But I'm saying that call that the connection, or the con with a double N. And the next thing we need to input is the series that we want to download. I'm going to call that series for now. And then we need the start date and the to date. But I don't want to use those names. I'm going to give them some other names. So I'm going to call it from date and to date of the data that I want to pull from Fred. But of course, we need some outputs. So we can call this index data is equal to the function because it's going to pull our data for us. But what we need to do is we need to specify what these input variables are. So we can say our connection is equal to Fred, built in, and that's exactly how you would do that. We can then say from date equal to, well, I'm not really sure. I want to see as far back as what I can import data from. Let's call this from the 1st of January 2000 for an example. But Fred will tell us what date range it actually had available and the data that it's been able to pull for us. And we also need the to date. Let's say we want it to be today. Easy, readable, understandable there. The last thing we want to pull in is our series. And the series that we want to pull in is the S&P 500. And this is just the character that the fetch function realizes or takes in to be able to pull the correct time series that you want to pull in. But of course, you can import other things like the NASDAQ 100, for instance, and I'll show you how you can actually create a more live document in just a few seconds. But this is literally how simple it is to pull in and make some connection to the Fred database. And what you have just seen me do is click this striped blue bar on the left to only run the specific section that I have in front of me. And what you'll see now is we have an error, but MATLAB is telling us that there's actually some unrecognized functional variable from date. So that's my from date. And where's that coming from? Well, oh, I see my from date is actually incorrectly spelled. So I just need to make that quick update, or there's a fix that I can use suggested by the live script. And what we'll see is the data has now been downloaded. We have some index data that is being pulled in as a structure array. We can see that there is additional information that Fred is telling us about. So like the date range, and this is the only date range available to us. So we tried to pull data from 2000, but we only have data available from 2011. And that's all right for the purposes of this demonstration. But the main crux of what we want to see is the actual data. And we can see that there's two columns. And the first column, of course, is going to be the date. And the second column is going to be the price of the index that I have just pulled in from Fred. But what we'll see is that this date format kind of looks something like Julian dates or something like that. So what I did before the demo is I just created a short helper function for me. And I made that helper function's name fetch data from Fred. And this is the contextual hints that the live script allows you to do to pick up either pre-built functions in MATLAB or helper functions that you have created. And I just press tab to complete that. But this function just does a little bit of formatting for me, not too much more code than what you have seen right now. And there we go. It has formatted the data for me really nicely in a table format, giving me a dates and a column headings that I can then use throughout the work. But maybe what we want to do now is once we've pulled in this data, we want to be able to visualize this data. And how we can do that is through the use of a task. And you can see that there's a whole bunch of different tasks available. The one for plotting that we're going to use now, but there's ones for optimization, all this pre-processing data, smoothing the data, trends, missing data, hint, that's probably what we're going to use. But for now, let's go and explore this data. As a disclaimer, we're not going to dive too much into the real technical detail of what this data set really looks like, but I'm showing you the tools that you can use to do those real deep dives. So the live task is now embedded into my live script. I want to create a plot. I know this is time series, so I'm probably just going to use a standard line plot, but I need to select the data I want to use. So my X data will probably be my index data, and then I need to select the specific column heading, which will be date. My Y data will probably also be my index data, and that will be the price. And you'll see that the live script runs automatically for you. It's loading, and there we have it, a formatted figure, and we didn't have to do any coding to get that out. But what if you want the code? What if you want to learn how you can programmatically do this? Well, this little drop-down gives you the generated code of what this app, lightweight app, has just done for you. And it's done that with a little bit of extra labels, legends, things like that. But cool. Once we have this, maybe we want to do some investigation, and we can use the tools that we have available to zoom in on our data. And what we can already see is, this data set is not continuous. There is some missing data. And this is probably due to things like the weekends and whatnot. And we probably want to be able to just clean that out. So what we can do is go and start cleaning that out with another live task. But what I'd like to mention is that you don't need the data feed toolbox to pull in any data. You can also import data using the import tool or your load function from mat files, Excel spreadsheets. And if you are an avid MATLAB user, you probably already know this, but there is so much available out there. You can also pull things from databases. I'll show you there's even an app for that. But I said we're going to clean the data. So let's go and do that. Let's insert another task for clean missing data. Task gets embedded into our notebook. We wait for it to load. So the first thing we need to do is we need to select the data that we want to clean. And the data we want to clean is this index data. So we select it, we get some more options. Well, we want to be able to clean all the supported variables in that data set. What we want to do is not fill the data, but we want to remove the missing data. But we also want to give the new data a new name so we can make it a little bit more readable. So we want to call that clean data, because clean data is a lot more readable after you've processed it, so we know what's going on and we can follow what's happening. But you'll notice that I now have a figure, and it's showing me that it's removed data. You can actually see there's some sort of trend from, I want to say, the weekend. But it's removed the data, and it's shown us where those indices are, and it's outputted our, can you just run that again? It's output our clean data into our workspace for us. But again, the code has all been generated for you. Literally, it was one line to remove the data, but to make a nice fancy plot, here's all the code that was used to create this plot. And you're more than welcome to go and integrate that, create functions from that, to really automate this whole process. But our data is clean, and we actually didn't have to write any code for it. But the next step that we want to tackle is just being able to split our data into its training and testing set, because we need to fit the data to our training set, and then we need to analyze the results on our test set. And I wrote a small helper function just to make the live script a bit neater, to split the data depending on the duration of, and I made a duration of 252. And in this context, it's 252 days, assuming that there's 252 trading days in the year. So we want to be able to forecast a year's worth of the S&P 500. So I'm going to run that just to get my training and testing sets out. And right now we're in a place where we've cleaned the data, we have training and testing sets, we can go and start fitting some models. And the first model we're going to fit is an ARIMA model with our econometric modeler app. And I keep talking about apps, but where are these apps? Well, they're in this top toolbar called apps. And if you press this drop down, you will see that there are an abundance of pre-built in MATLAB apps that you can use depending on the type of toolbox that you have. But I have my favorite apps on the top here. There are apps for machine learning and deep learning classification, deep network, shallow neural nets, regression, experiment managers. But there's apps for things like curve fitting, for fitting different distributions, for optimization problems. There's also more computational finance apps, such as the econometric model app that we're going to use. But there's a Bidding Explorer app. If you are fitting credit scorecard models, you can do that all quite interactively. But then there's an app to explore databases, like your relational databases, SQL databases. You don't have to write any SQL code. You can use the app, explore the database, and it will generate the code for you to be able to pull that specific data from your database. But we're going to use the econometric model app for this example. If you want to find out about any of the others, you are more than welcome to come and chat to me. We'll just give that a second to load. But once that's open, you'll see that this is the econometric model app. Everything's grayed out because the first step we need to do is be able to import the data we want to fit our model to. So we can select the import tool. And then it shows us all the variables in our workspace that we can import into this data set. And the data we want to import is this train data. So we can select it, we can import it, and immediately a time series plot gets created for me. And you'll see that here's where the data sits. There's no models that have been fit yet. But where do you start? Well, the first thing you probably would start off with is running some different tests, your stationarity test, your heteroscedasticity test, or autocorrelation test. And for the example, I'm going to just run a KPSS test. You can change different parameters if you would like. But then what you do is you can see you have some null hypothesis. The price is trend stationary. If we run this test, you'll see a new line is formatted, and it tells us that was the null hypothesis rejected? Yes, it was rejected. So that means that our price is not trend stationary. And you can use all this information from all these different tests to do a whole bunch of different analyses. Maybe you want to log and then difference this data. You can do that without a problem. But for our purposes, we just want to work with our price data. So we select the price data we want to fit an ARIMA model, but there's a whole bunch of different other models that you can fit should you wish to do so. So we fit the model, we have another pop-up that allows us to input some parameters. So the first thing we want to do is maybe we want to have our autoregressive order to be 3. You're doing a whole bunch of testing. Our degree of integration should be 1, and our moving average order should be 2. Yes, I'm picking specific values because I have already done this, and we have another script that goes through this whole process of picking the optimal values and seeing how this whole process goes. But for the example, I'm just going to stick with these values. And what I'm going to then do is I can just press estimate. We give that 1 or 2 seconds and it fits our estimate model. And then we get a model summary of everything that we just did. We have the model fit, we have a residuals plot, we have our goodness of fit values that you can use to compare your different models with. And we have other parameters that you would need if you are in the econometric modeling space. But once you're done, you can export all of this. So you can generate a function to fit the model as we just did. But you can also generate a report to show the process that you've gone through, and this will save it as a PDF, and you can use it at a later stage. But for the purpose of what we want to do, we're just going to generate a function. And you'll see that this function fits an ARIMA model with all the parameters that we've selected, and then it estimates that model with the input of train, where that train becomes just the price data that we are fitting to. But now we want to be able to use this generated model for ourselves. So what we can do is we can just save this, and we can save this in our projects of our helper function. We can save it there. And then what you can do is you just take the function name and you copy that and paste it into your live script to start giving you results. But I want to maybe change the output name because it's not too readable for me. I want to make that est model for, this is my estimated model. And then you'll see that the estimated model gets pulled into our forecast and our simulate functions for our different models. And these are just 2 different ways that you can use to do the forecasting that we are looking at. And once that's done, you can press the bar on the left. It will start running this all for us. We get some outputs with our ARIMA that has some properties. Our simulate is simulating 100,000 different parts, which is really cool. But maybe you want to know, well, how does the simulate function work? So the way that you can do that is you highlight it, you can right-click, say, help on simulate, and that will open up the MathWorks documentation for you of exactly how that function works. And I can actually open this a bit bigger. And you get all this information, plus some examples of how specific functions work really, really quickly. Cool. So once that is done, we have now fitted an ARIMA model. We want to be able to fit our machine learning regression model. So the way that we can do that is, firstly, we only have price data. So what we need to do is just do some sort of feature engineering per se. And I've created a function that does this for me and adds some predictors by calculating a moving average with different window periods. And if you right click and open that, it will open the one I have created, and that is it over there. So once you get this, you're more than welcome to play around. But with the new features, we just have to create new training and testing sets with the same duration that we have used earlier, because we need to be able to compare our apples with apples. And now we have a training and testing set, and we're ready to fit a machine learning model. And the way that you can open up your machine learning app or your regression learner app is by either inputting this code into the command window, or you can go to apps and you can say regression learner app. And that will open up the regression learner app for us, which give it 1 or 2 seconds because a lot of things are running. And there we have it. And again, the first thing we need to do is we need to start a new session with new data. So we can press our nice gold plus sign, which opens up a different little app for us to select the data we want to use. And the data we want to use in this case is our train ML, because that's the data set I split it up to. And MATLAB figures out what the response is. So if you select from the set variable, it says my response is the price column that was in that data set. And it's picked out that my predictors are all the other columns for us. We can then go ahead and we can start choosing what type of validation set we want. So for my example, let's use a 25% holdout validation, just as the example. We can start the session. Everything loads up for us. And what you'll notice is we haven't generated any code yet. And that's really the beauty of what we are doing. Something I just want to do quickly is start the parallel computing toolbox on my computer, because I'm going to show you the additional functionality that you have. But once we have our data in, you can go and select or deselect other features that you don't want to use. I think it's opening. But what you'll notice is that there's a whole bunch of different models that you can fit. Anything from linear regressions to regression trees to SVMs to GPRs to ensembles and even some neural nets that are available within the regression learner app. Cool. Now that my parallel computing toolbox is open, I want to select which tools I want to train. But my feature selection is open now. You can, if you have 10, 15, 20 different features, you don't have to reload in tables. You can select and deselect different features to do this whole process as you wish. But perhaps I want to train a couple of different models. So what I can say is I want to train all the linear models. And the reason I started my parallel computing toolbox is because I can select use the parallel feature and train. And that's how you train the model, even if you don't have the parallel features available. You can now train the models, and it's going to go and train all those models at the same time, of course, depending on number of cores and things you have done, but that's very technical. But you'll see that all my models are being trained at the same time. So we give that a couple of seconds to train before we move on to the next part of the work. And you'll see that the models have started training, and the best model that it's telling me is a stepwise linear model, and it has an RMSE of 48. That's why it's saying this is the best model. It's indicating it to me in bold. But if you're not just looking at the RMSE values, you will see that there is a model summary that tells you all the training results from your MSE or R-squared values, the model types, the optimizer options, feature selection. But perhaps you want to interrogate this model more. You can use the response plots that are available. You can have predicted versus residual plots all in this environment to see how well your model is performing. But once you're done, you can export all of this stuff. And what I'm really going to look at is if you export a function, it will export the function of this process you went through to retrain a model with new data, but the same model that you have created. For what I want to do is, for this purposes, I'm going to export the robust linear model as an example, but I don't want to retrain my model. I actually want to make predictions. So I can export this model as a MATLAB object, and we can leave that as trained model. Minimize that. And my trained model is now in my workspace, and I need to make the prediction. And the way that I do that is I can say that my output, as we always need, is called reg price, or equal the trained model, this one that we have, the predict function that is pre-built, and I need to just input my testing data or the data that I'd like to make the prediction on. And I can run that and make the prediction that we'll show in the graph later on. Cool. But once I'm done that, we can quickly look at how do I call the Python version of all of this that maybe my colleague has created and I just want to use it off the bat. And the first thing that we need to do is just check that the Python version is on our machine, because you need to have Python installed. So we can say that PE is equal to pyenv, which is the pre-built-in function to determine if you have a Python environment on your computer. And we'll let that run. And while that's running, we then want to be able to call our Python script. And the way that we do that is with the pseudocode I've written over here. We call that our output fit is equal to pi, because you need to specify that we're calling a Python module, dot the function name, which is this one over here, predict index price functions. We're going to call that predict index price functions dot the function name that we want to use within that file. And in our case, it's called Auto-Arima, and we want to input to that. And then we can run that. And you'll notice that the script that your colleague has created even prints out some variables. It's the person has created a really nice model that auto fits the ARIMA to determine your P, Q, and D values to find out which one is the best. And we'll give that some time to run. I believe the resources on my computer are being eaten. So there is an error, unable to resolve the name, and it's probably because I have not typed in the correct name. Yes, and that is correct, because the function that has been created is actually Auto-Arima FCN. We can run that again. And then we can see, as I was saying, we're looking for the optimal ARIMA model to predict to our training data set that your colleague went to code out in Python. And it does a few iterations before it gets to a usable model. And we'll let that just run. It's almost done. Cool. And you'll see that they've outputted some cool information for you, telling you that the best model is an ARIMA 312. But at the same time, they actually went and fitted that model to some data and made a prediction for you. They knew that you were trying to forecast 1 year, so they did the same. And we have a Python ND array that has come out. And what's nice is MATLAB is telling us that to convert from this type of Python data structure, we just need to use the double format. So we want to be able to use this data in our graph, so we can say predicted price is equal to double. We take the output fit of that model, the array, but we see that that is a row vector. We want it in column format, so we just add the little apostrophe there for us to transpose. Great, and there we have our array that we can use in our results. So the last thing we want to do is be able to visualize and compare these results. And I've written a function that just plots all the data for us so that we can visualize it and we can see where our prediction start date is with a nice little legend. And what I've added in is a live a control that changes our line width value for an example. So if we change this value, you can see it will update the function, replot everything. But what this is useful for is if you're trying to check different parameters without having to delete the value, putting a new value, things like that, you can add these different controls, and you'll see there's a lot, like numeric slider, drop downs, checkboxes, edit fields, to make this really a live document. But what's also advantageous of that is you can create a functional mock-up unit if you're creating an app with something like App Designer that you want to deploy to end users, and maybe they want to control different values. But then I've also created a couple functions just to compare and plot a table of the different RMSE values so you can compare your different models. But you're more than welcome to go and interrogate this to see what these different models look like. And we can see that the models look quite similar in terms of the ARIMA models. But you're more than welcome to go and investigate that. And that is everything I have for the demo. So let me jump back to the slides just to close off for us. So we looked at the demo. I just want to touch on a couple things before we finish off. The first thing is the Computational Finance Suite and what this is. And this is really 12 bundled and cost-effective tools that allow you to do a lot of the work I did today, but you can develop applications in risk management, investment management, econometrics, and all the whole list that I have over there. And just to mention, the couple tools I used just in creating 3 models are the ones I've highlighted in red on the right-hand side. And this really allows you to create many different models really, really quickly. It allows you to also work with so many different data sets and use so much functionality across the spectrum to help you save time and try and rapidly prototype and collaborate between different environments. And the last thing is, how does this financial modeling workflow and where do these tools sit? And this is where they sit in. They help you to access data. They help you with the parallel computing to rapidly train different models to do parameter sweeps and things like that. And then you have your domain-specific tools that really can be used cross-domainly to perform a lot of the different analyses. And just to touch on the key takeaways that you can really develop as fast as you think. With the live script and the tools, you can create transparent models. You can really make sense of your data, and you can make use of the power of the integrated financial workflows to really develop powerful models for your work really, really efficiently. So what's next? Stay tuned for more. We do have a enterprise deployment webinar in the pipeline. If this is something you're interested in, more than welcome to come and chat to me. But we will have a Q&A session. Right now, I'll go see in the chat if there's anything there. But we do have some FAQs at the end that we can go through. But more than anything, speak to us. Reach out to me if you have questions. Reach out to our tech support queue if you have any technical related queries. And there's also abundance of information online and resources available on the MathWorks website, on our website as well, where there's videos and examples that you can use. And of course, there's training courses and workshops available. And if you want to find out more, you're more than welcome to come and speak to me. Thank you very much. Let me open up the chat and see if there are any questions in the chat. Otherwise, I can open up the floor. I don't see there's any questions in the chat. Does anybody have any questions they'd like to ask? Yes, I will be sharing the code and the slides. Everything will be shared after the webinar in the next few days. Thank you very much. Cool. If there's no questions, I'll go and step into some FAQs. So some FAQs that we have is, can I integrate MATLAB with other software platforms such as R, Power BI, and not just the Python that I showed today? And the answer is absolutely yes. But at the same time, can MATLAB be deployed to the cloud or a virtual machine? Again, yes, that is definitely possible. And what you can interoperate with and integrate with are so many different platforms. Perhaps you have legacy code or already standing infrastructure that you want to be able to make use of. You can integrate with so many different business systems, data sources, as well as cloud and virtual machine software. The third one that we get is, Leo, my modules run extremely slow. How can I increase their speed? And there are already several ways to do this. And the first is to use the code profiler, which will allow you to identify specific bottlenecks in your code. And I've added a link here that you can use to find out how you can use this when you receive the slides. The second one is parallel computing and the parallel server. You can really use these tools to work with large amounts of data, with creating many different models, doing things like parameter sweeps. And you can really leverage the power of high performance software or hardware. Great. Another one that we get is, what are common ways to understand the contributing features of a model? And in AI, machine learning, and all of these things, you can use things through responsible AI interpretability that may help you to understand the inner workings of a model. The last one is, I have developed beautiful models, but how can I share this with end users who aren't necessarily model developers? And it's really easy. You can create apps with App Designer in base MATLAB, and you can then share these as standalone executables or as a web app with the web app server. So your end users just see the front end of a nice interface, and all the hard work and models that you've developed are working in the background. And if this is something you're interested in, chat to me. More than happy to have a conversation. Great. Besides the FAQs, has anything sparked anybody for a question? You're more than welcome to put it in the chat or unmute your microphone and ask me. Great, no questions. Well, that is all I have for you today. Please reach out if you have any questions. More than happy to answer them. But have a wonderful day further, everybody.
Thank you.
Thanks, Leo.
Thank you, Leo.